Okay, so here we are in section 13.5. We're talking about volume and mass. So we're finishing our three-dimensional measurement. Last section, 13.4, that was surface area. Now volume and mass. Okay, so we start off with our Common Core Standards grade 5. In grade 5, they will find the volume of a right rectangular prism with whole number sides, and on you go. Some of this stuff will be done in grade 5. So let's talk about the volume of a right rectangular prism, which 5th graders will do. Well, look at this. It's like a big giant Rubik's Cube. I think this is a great diagram just to give us a nice physical feel of volume. Really helpful. Take a look at this thing here. So notice this big Rubik's Cube three-dimensional thing has 8 cubes on the bottom, right? 1, 2, 3, 4, 5, 6, 7. It's 8 cubes wide, and it's 4 cubes deep. So 8 cubes wide, 4 cubes deep. And so the bottom is 8 by 4. And it's 5 cubes tall. All right. So how many total cubes are there? How many total cubes in this prism? Well, how many on the ground? Let's ground or base. Let's call it base, ground level, base level, whatever. The base, do a little bit neater writing there. The base is 8 by 4, right? There's, 8 rectangles across, 4 rectangles deep. It's 8 by 4, 32 rectangles. 32 cubes. 32 cubes on the base. And then there's 32 cubes on the second level. 32 cubes on the third level, 32 cubes on the fourth level, and 32 cubes on the fifth level. In other words, because all the levels are the same, aren't they? So in other words, we just take 32 times 5, which would be what, 160 cubes. There's got to be 160 cubes because there's 5 levels, each one having 32. So think about what we just did there. We took this, which was the base, times this, which was the height. Right? We just found out what was on the base level and multiplied it by the height. Well, that is basically how you find the volume, and that's volume, of any three-dimensional shape that comes straight up. That doesn't, like, it's not a pyramid, doesn't come to a point or something like that. Okay, so the volume again is base times the height. And what is the base? The base of this shape is length times width, because it's a rectangle. Length times width times height. That's base, length times width times height. So there's the volume formula, length times width times height. But the easy way to remember it, it's just ground floor, base, times the height. Right? Just like we did for that right rectangular prism. There were 32 on the base. It was 8 by 4. And there are 5 levels of 32. It's just base times the height. So same thing here. Here again is our volume formula. Volume is base times height again. Now, if it comes to a point like a pyramid, you throw a 1/3 in front of that. It's only 1/3 the volume it used to be. 1/3 the B stands for base. Right? The base is here, the area of the base. I don't know why they have these upside down. That's fine, I guess. Times the height. Now, what about if it's like a soda can, a right circular cylinder, we call that. It's still the same formula. See how it's base times the height. Whenever an object goes straight up and down, it's just the ground floor times the height. But what is the ground floor on this one? The base is a circle, pi r squared, isn't it? You know the area of a circle, pi r squared. So it's going to be pi r squared, because that's the base, times the height. Volume is base times height, pi r squared times height. That's the formula for volume for a right circular cylinder, a soda can kind of shape. Now this is going to be the same thing. This is a soda can, but it comes to a point. So you do the same formula, but you throw a 1/3 in front. 1/3 pi r squared h. See how 1/3 and 1/3, when they come to a point, they only have 1/3 of their volume? Then we have a special formula for a sphere. A sphere is 4/3 pi r cubed. That's the formula for the volume of a sphere. 4/3 pi r cubed. Now we're going to talk about converting metric measure volume. So specifically, we have this table here. This is how we measure volume. So liters, this is for volume, liters, and then of course, you know, decaliters, hectoliters, kiloliters, deciliters, centiliters, milliliters. And specifically, here's a nice connection. 1 cubic centimeter, that's volume, cubic volume, is 1 milliliter. They set that up very nicely in the metric system. We'll remember that and use that. 1 cubic centimeter is 1 milliliter. All right. And then there's converting. This is the same converting table we used before. To convert in the metric system, you just, you know, jump to the right. But for volume, we triple the number of steps, because volume is cubic units, right? Cubic meters or cubic millimeters or cubic kilometers. So you have to triple the number of steps. Remember, for area, this is for volume. For area, which was square meters, square millimeters, square kilometers, we doubled. We doubled for area, triple for volume, and then just normal length, meters, millimeters, kilometers, we just did single. We didn't double or triple the number of steps. So we'll see that when we get to the conversion problem. So it's the same exact thing, you just triple. So say you go from cubic meters here, and you go boom, boom, to cubic centimeters. That was 2 jumps. But then you go times 3 because it's volume. That would be 6 decimals to the right. You just triple the number of jumps. We'll see it when we get to the conversion problems. All right, let's dive in. Oh yeah, one more thing for the homework. Mass. What's the difference between mass and volume? 3 centuries ago, Isaac Newton pointed out that the word weight is used for what we really mean mass. Mass is a quantity of matter, as opposed to weight, which is the force exerted by gravitational pull. You know how they say you'll weigh something different if you go to the moon? As the moon is smaller than the Earth, it's 1/6 of the mass of the Earth. And so if you go to the moon, you will weigh 1/6. So like if you weigh, let's say 180 pounds on the Earth, then divide by 6, you'll only weigh 30 pounds on the moon. Why? Now, your mass, the amount of body you have, is the same on Earth or the moon. Does that make sense, the difference between mass and weight? Your mass doesn't change. The amount of actual body material you have is obviously the same on the Earth or the moon. Your amount of body material hasn't changed. That's your mass. But your weight will change. You'll weigh 180 pounds on the Earth, only 30 pounds on the moon, because the moon has a weaker pull on objects. The Earth has a stronger pull. So that's the difference between weight and mass, and that's an important distinction. And we have some conversions. Grams is the basic unit of mass. So grams, the metric system, a fundamental unit for mass is grams. So we use grams, and then we convert to decagrams, hectograms, kilograms, decigrams, centigram, milligram. Just like all the other systems. So we start with the basic unit, gram, and then we put those same prefixes, deca, hecta, kilo, deci, centi, milli. Put those same prefixes on it. That's what makes the metric system so nice to use. So the basic unit of mass in the metric system is grams. We use grams. And and then for volume, we use liters. That's for volume. All right. And one more connection. Again, there's what we saw. 1 cubic centimeter or 1 milliliter of water is 1 gram. 1 gram. That's the mass of water. So that mass of water, that's how much. And then over here, 1 decimeter, 1 cubic decimeter, a liter of water is 1 kilogram. That's a connection between volume of water and mass. So there we go. Metric volume, capacity, and mass. So volume and mass. All right, to the homework we go. Complete each of the following conversions. So we're going to take 5 cubic meters and change it to cubic decimeters. So I'm going to put the scale right here again. The conversion in the metric system. Right in the middle we have meters, and this will be decimeter, centimeter, millimeter. The other way we have decameters, hectometers, and kilometers. Okay, so we're going from cubic meters to cubic decimeters. So we're starting here and going 1 jump to the right. But then these are third power units, so 1 jump times 3 for volume, triple units, is 3 decimals. So I'm going to move 3 decimals to the right, aren't I? Because that jump went to the right. So I take I'm going to take this 5 here, 5. Let's bring it right up here. 5 cubic meters. And where's the decimal right now? Well, I don't see a decimal, so that means it's at the end of the number. Just like if somebody forgets to put a period on a sentence, you know where it really goes. It's at the end of the number. Okay. Decimal 3 to the right. 1, 2, 3. So those will bring in zeros. 5,000 cubic decimeters. Okay, let's try the next one. On the next one, 625,000 cubic meters to cubic hectometers. So if you start out in meters, go to hectometers, it's 2 jumps to the left. So 2 jumps left times 3. We got to multiply by 3 because we're talking cubic units here. Is 6 decimals left. So I've got to take that 625,000 with the decimal right there. And I got to go how many? 6 decimals left. 1, 2, 3, 4, 5, 6 right there. So 0.625. You don't need those extra zeros. They don't contribute anything. Next, let's try the next one. 6,000 cubic millimeters. So now we're going from cubic millimeters right here to cubic centimeters. That's just 1 jump to the left. So this is 1 jump left times 3 though, because these are cubic units. 3 decimals to the left. 3 decimals to the left. Okay, so I'm going to go 3 decimals to the left. So I'm going to take that 6,000 number. Where's the decimal right now? Right, it's at the end. If you don't see it, it's always at the end. 3 left, 1, 2, 3. There it is. So 6. You can write 6.0 if you want, but it might as well just say 6. Same thing as 6.0 cubic centimeters. Okay, now that's the end of the metric. These last two, unfortunately, are the English system. They're not the metric system. So what does that mean? How do we convert within the English system? We have to use fractions instead of decimals. It's a lot harder. So, okay, so let's take this 200 cubic inches, put it over 1, multiply. Now what am I trying to get to? I'll put over here cubic yards, huh? Okay. So I'm going to have to remember how you convert with in the English system with the fractions. Whatever's on the top, you put on the bottom. Just regular inches at first. I know we got to make it third power, but we do that later. First, put inches. Now, what can you put on the top? What's easy? What do you know? Don't do something hard. Just what do you know easily from inches? Feet, right? So feet, and 1 foot, 12 inches. That you know easily. Now, there's no third powers on anything yet. Now we bring in the third powers. First, you write down the units. 1 foot, 12 inches. Inches on the bottom because I want the cubic inches to cancel. But then I've got to cube. When you cube the unit, you've got to cube the number. Third power of the unit, third power of the number. Same thing on the top. Third power of the unit, third power of the number. You got to third power everybody at once. So, okay. So then cubic inches will cancel out. Now, are we done? Not quite. We're not where we want to be yet. We're in cubic feet. We got to get rid of cubic feet. So put feet down here, just regular feet at first. And we want to get to cubic yards, so put yards on the top. And what do you know about the connection there? Hope you know 1 yard is 3 feet. It's a good one to put on your 3x5 card for the next exam. 1 yard is 3 feet. So 1 yard, 3 feet. No cubics yet. And now bring in the third power. Third power. Third power, third power, third power. All the numbers and the units. Now cubic feet cancel. I'm in cubic yards. I'm where I want to be. So, okay, so great. So what do I do? Now just any numbers in the top, stay in the top. What do we have in the top? 200. It's 200 times 1 to the third power. That's just 1. Times 1 to the third power. That's just 1, right? 1 times 1 times 1. Over. Make that a little neater here. Over what's in the bottom? 12 to 1 times 12 to the third power times 3 to the third power, right? Okay. And so now what does that equal? On the top, it's just 200 because 1 to the third power, 1 to the third power, that's just 1. 200 times 1 is just 200. On the bottom, use your calculator. 12 to the third power is a big number. I'm going to use my calculator. 12 times 12 times 12, 3 times, times 3 to the third power, times 3 times 3 times 3. I'm getting 46,656. Now, we have to reduce that fraction. Some of your calculators will do it automatically. How are we going to reduce that? Well, I think... I don't know exactly. I think like 4 will go in. Just try it. Try dividing top and bottom by 4 in your calculator. That'd be 50. And then on the bottom, use your calculator. 11,664. That was good. Now divide by 2. Top and bottom. We get 25. And the bottom, 58.32. 58.32. And that's what they want. They want a fraction answer. So it's 25 over 58.32 cubic yards. That was a lot of work. Okay. Now, final problem. We'll do part E here. Bring it down here. 0.2 cubic feet. English again, so put it over 1. We got to do fractions. And what do we got to get to? We want cubic inches. All right, next step, we're going to put feet on the bottom, not cube yet. And what do we know about feet? Well, 1 foot, 12 inches, right? So, and then we bring in the third powers. So third power, third power, third power, third power. So I just third power everything. Cubic feet will cancel, and I'll be in cubic inches, which is what I want. Okay, so I've arrived. Now I just got to calculate it. So anything on the top, what do we have on the top? 0.2 times 12 to the third power over, on the bottom, 1 times 1 to the third power. Well, that's just 1. The bottom is just 1, so we can ignore it. Use your calculator on the top. 0.2 times 12 3 times. I'm getting 345.6. There we go. Let us do a decimal on this one. 345.6 cubic inches. There we go. All right. On to number 2. Now we're going to find the volume for each of these figures. So we've got a right circular cone with a hemisphere. So we have a hemisphere. That means a half of a sphere, right? We talk about whether you live in the northern hemisphere or the southern hemisphere, the Earth. So it means, half the Earth, the northern half or the southern half. That's a hemisphere, a half a sphere. And then this is a right circular cone, so like an ice cream cone. It's got a half a dome on the top, half a sphere on the top. Okay, let's find the volume. So the volume then is going to be in 2 parts. We have the volume of the top. So this is going to be, this is the volume. What's the volume for a sphere? If you go back to a whole sphere, a whole ball, there it is, a sphere, 4/3 pi r cubed. That's for a whole sphere. We'll just cut that in half, 4/3 pi r cubed. So we'll take 4/3 pi r cubed, and then we'll just divide it by 2, because it's half of a sphere. The radius is this 7. This is the radius, 7. Goes from there to there, from the middle to the edge. That's 7. So that's 4/3 pi times r, which is 7 cubed, and then divide by 2. Okay, so what do we get for that part? Okay, so then how do we figure that out? Let's take it right over here. So I'm going to double check. Okay, so yeah, so this is going to be 4/3 pi, and then 7 to the third power. If you take your calculator, 7 times 7 times 7 is 343, and then divided by 2. I'll just put it like that. So I get the 4/3 the pi, the 7 to the third power, which is 343, divided by 2. So you just put the 2 in the denominator. That's what dividing by 2 means. Okay, now how do we simplify that fraction? Remember, you can let's just cross cancel. 2 goes into 4 2 times. So we're left on the top with 2 times 2, 343, which is 686 pi over 3. See how I got that? So the 2 went into the 4, 2 times 343 on the top, made 686. This pi is really over 1, right? Anything alone is over 1 and goes to the top. Remember that? Anything alone, like pi, is really over 1, goes to the top. That's why the pi goes up here to the top, over the 3 on the bottom. Okay, so there's the volume of this half dome part. Now, that's just the half dome. now the half sphere, and now we need the volume of this part here. So the volume of that, now that's a right circular cone. Let's go back at the volume formula for that. That's one of these, 1/3 pi r squared h. So this is going to be 1/3 pi r squared h. So we did the volume for a sphere, cut it in half because it was only half a sphere. And now we have the volume for the cone. So the r, the radius again is the 7. The height is the 18. And so that's 1/3 pi 7 squared is 49 times 18. Now this 49 is over 1, 18 is over 1, and pi is over 1, and the 3 goes to the bottom, right? So this will be 49 times 18. Let me do a better job here of this. So it's going to be 49 times 18. That's 882 pi over 3. So there we go. So there's the volume of that. Now we got to put those together. Total volume is the two parts added together. So this answer, 686 pi over 3, plus this answer, which is 882 pi over 3. We have to add up the half dome part with the cone. So adding up, so on the top, it's going to be common denominator of 3, 686 pi and 882 pi. So add those up, 1568 pi over 3. That's the total volume of that, and that's cubic centimeters. 1568 over 3 pi. You can just put that pi in the front or in the top. It's the same either way, right? Because again, anything in the front is really over 1. It's the same as being in the top. Either way, it's good, and Math Excel knows that. It'll take it either way. So we found the volume of the half dome, the volume of the cone, added the two together, got the total volume. All right, now let's try this next shape. We've got a right triangular prism, this shape right here, this tent kind of thing. We want volume. We want to fill it up. So remember, whenever you have any shape that goes same shape to same shape, see here we have a triangle to a triangle. So whenever you have a triangle base, you see we have two triangles with straight sides in between. It's just laying down, but it's the same thing. Whenever you have a three-dimensional shape that has the same shape on the ground and the top, and this one's just laying down on its side instead of standing up, but whenever it has two of the same shape, that's a prism. That's what it means to be a prism. And when it's got straight sides in between, the volume is just going to be the area, the base area times the height. You just find the volume, the total volume will just be the base times the height. Now the base is a triangle. So the base, being a triangle, is 1/2 base height of the triangle. This is height of the prism. There's two heights going on here. We've got to be careful. Okay, I'm not writing very neatly here. Height of the prism. So the base of the prism. Yeah, here, let me write this a little bit better. Base of prism times height of prism. Okay, so what's the base of the prism? It's a triangle. This right here, this is the base. It's a triangle, which is 1/2 times base times height, right? Height of that little triangle. So that is a half. This is the little base of the triangle right here. And this is the little height of the triangle, because that comes straight down to the base. 1/2 8 times 8 times the height of the prism. What's the height? This is the height of the prism. Again, it's just laying down. They laid this one down, but this is height. Right here, this 16 is the height of the prism because it goes straight between the two bases. They've just laid this one down. So the base in a prism is always what there's two of. There's two triangles here. So the height is what goes in a straight line at 90 degrees between the two bases. So that's the height. That is the 16. So do that on your calculator. And it comes out to be 512. 512, what are the units on that? Cubic centimeters, because again, this is volume, cubic units. So that was a lot easier than the other one, than part A. All right, so again, the volume of any shape that's a prism that has two of the same things, like two triangles, it's just the base area, the area of the base, times the height. The area of the base is a triangle, so it was a half base times height, times the height of the prism, which is 16. There we go. Now, part C. They want us to find the volume of that right circular cone. So, you know the volume of a cone. We just did that one. The volume of a cone. We'll go back here again. There it is. 1/3. There's a cone. 1/3 pi r squared h. So it's 1/3 pi r squared h. 1/3 pi r squared h. So again, notice how it's just the base. The base is pi r squared times the height. See how all these volume shapes, almost all of them, are basically area of the base, which is in this case a circle, pi r squared times the height. And if it comes to a point like a pyramid or a cone, you throw 1/3 in the front. So it's 1/3 pi. What's the radius of this cone? Well, here's the radius. The radius is the 2. 2 squared. What's the height? The height is the 12. So there we go. So I'm getting 1/3 pi, and then this is 4 times 12, 48. And then 3 goes into 48, because that's a 48 over 1. 16 times. So that'll be 16 pi equals 16 pi, 16 and pi, 16 pi. And what are the units? Cubic centimeters, again, because it's volume, cubic units. How about the sphere down here on part D? Formula for the volume of a sphere. Go back here. There it is, 4/3 pi r cubed. So the volume equals 4/3 pi r cubed. So that's 4/3. The pi, the radius is the 11 cubed. It's 4/3 pi, and the 11 cubed is 1331. 1331. Now that's over 1, right? So then you multiply that in the top. 4 times 1331. So I'm getting 5324 over 3 pi. Right here, 5324 over 3 pi. Like that. And what are the units on that? Again, cubic centimeters, because volume is cubic units. Okay. E. Right circular cylinder with a hemispherical top. So here we go again with the shape that has a half dome at the top. So we're going to say we have the top. The top is a sphere. So that's going to be 4/3 pi r cubed divided by 2. Do you see why we divide by 2? Because it's half. This is only half of a sphere, right? Half a ball. So 4/3 pi r cubed divided by 2, because the formula for the volume, 4/3 pi r cubed, 4/3 pi r cubed, that's for a whole sphere, and then we have a half a sphere. So divided by 2. So that'll be the top part up here. So what becomes of that? Well, that's 4/3 pi. What's the radius? Now the radius is from the middle to the edge. That's the radius. 80 is all the way across, so the radius must be 40, huh? 40 cubed divided by 2. So that's going to be 4/3 pi, 40 cubed. That's a big number. 64,000 divided by 2. So I just did 40 cubed and divided by 2. So that's going to be 4/3 pi divided by 2, be 32,000. And this is over 1. So multiply 4 times 32,000. That will equal 128,000 pi over 3. So that's the volume of the half dome top. And now we have the volume of the cylinder. The soda can, this shape right here. The volume of this shape. So we need to figure out what's the volume of that soda can. Well, cylinder, if you go back, volume of cylinder, it's right here. Cylinder, pi r squared h. Pi r squared h. Makes sense because the base is pi r squared. It's a circle, right? The base is a circle times the height. Pi r squared h. So it's pi. What's the radius again? Radius is the 40, isn't it? Because the radius is from the middle to the edge, which must be 40. 40 times the height. This must be the height over here. The height must be the 100. So we have, what's that going to be? Use your calculator. 40 times 40 times 100. So I'm getting 16040 pi. It's 160,000 pi on that. Okay, so we have this answer for the cylinder. We have this answer over here for the half dome. Half dome top. Okay, now, so the total volume is going to be those added together. Total volume is going to be the 160,000 pi plus 128,000 pi over 3. Now, how do we add those two things together? We got to get a common denominator. See how they tell us they want fractions? So we got to put this over 1, and then you got to multiply top and bottom by 3, and you'll get 480,000 pi over 3 plus 128,000 pi over 3. And then you can add those together because they have the same denominator now. If you add those together on your calculator, you're going to get 608,000 pi over 3. So there is our answer. 608,000 over 3 pi. And what are the units? Again, volume, cubic units, cubic centimeters. There we go. That's a hard one. All right, so now on number 3, they want us to convert some units. Okay, so on this one, we're converting units within the metric system. So that's not too bad. Let me put the unit chart over here again. So that you want to put on your 3x5 card for the next exam. So meters in the middle, and this way is decameters, hectometers, kilometers, and decimeters, centimeters, millimeters. Oops, I don't know where there's millimeters. Okay, so where are we starting? We're starting, on this one anyway, we're starting with 400 cubic centimeters. And I'll just, I'm supposed to do part A, huh? Let me go over here to part A. Part A, 7 dm squared, decimeter right here. Starting here. And we're going to go, first off, going to go up to cubic centimeters, so that's 1 to the right. So that becomes 70. You just move the decimal 1 to the right. The decimal's right here. And then we're going to go from decimeters to liters. Now what are liters? Let's go back and find that out. Remember, I think back here, didn't we have, there it is. 1 cubic centimeter is 1 milliliter. So let's start with that one. 1 cubic centimeter. This and this are the same. A cubic centimeter is a milliliter, so we can just jump that straight down. Now, how do we go from milliliters back to liters? Well, this could be liters in the middle is same as meters. Remember, liters or grams on one of our future problems down here in number 5. We'll put grams in the middle. Remember, the unit in the middle is the base unit, whether that's meters because you're measuring a length, or liters because you're measuring a volume, or grams because you're measuring a mass. Length or volume or mass, it's all the same base unit, and then we would have deciliters, centiliters, milliliters, decaliters, hectoliters, kiloliters, and we'll do the same thing in a minute for grams. Okay, so now with that in mind, we're going to say, okay, so if we are going from milliliters here at 70 milliliters to liters, so from milliliters back to liters, 1, 2, 3 jumps to the left. 3 jumps to the left, so I got to take that 70 and go 3 left. 1, 2, 3, so 0.07 liters on that. 0.07 liters on the, wait a minute, did I make a mistake? I messed this up, didn't I? Let me back up here. This is all wrong. I forgot about the cubic units and the jump. Yeah, didn't I? Let's go back. Sorry about that. Let's try it again. Back on the first one. From cubic decimeters, right here, decimeters, we're jumping to cubic centimeters, which is 1 jump to the right, but I forgot these are third power, so times 3. So you take the 7.0 and go 1, 2, 3 to the right. That should be 7,000, shouldn't it? 3 jumps to the right. I messed that up. And then that 7,000 just comes right down here because, again, the top and the bottom are all going to be the same. Because a milliliter is the same as a cubic centimeter. That's what we saw back here. A milliliter is the same, where is it? Right here. A cubic centimeter and a milliliter are the same. So that'll be 7,000. Now, let me go to liter. Now, to go from milliliter to liter, again, let's do that. Milliliter here to liter, 3 jumps to the left. So take that 7,000, go 3 jumps to the left, it's back to 7. Right? 1, 2, 3 jumps to the left, it's back to 7. So there we go. Now it's correct. Let's try the next one. 400 cubic centimeters. I can jump it down here right away because remember, they're the same. A cubic centimeter is the same as a milliliter. Just put it right down there. Now how do we go to there to cubic decimeters? So if I'm going from cubic centimeters here to decimeters, that's 1 jump to the left, but you got to go times 3 because of the third power. So it's 3 to the left. So if you take that 400 with the decimal right there, go 3 left, 1, 2, 3, it's going to be a 0.4, isn't it? And now, can we go from milliliters to liters? So from milliliters to liters, here's milliliters, 1, 2, 3 jumps back to liters. So take that 400 again, 3 jumps back, 1, 2, 3, 0.4. Oh, you know what? Those middle two are the same. I should realize that. A cubic decimeter is a liter, isn't it? Let's go back and see that. Where was that? I think it's right here. Yeah, 1 cubic decimeter is 1 liter. 1 cubic decimeter is 1 liter, so they're going to be the same. I see now. Thought I need to work so hard on this. Those middle two are always going to be the same as each other. So let me erase this. So those outer two are going to be the same as each other, and these inner two rows are always going to be the same as each other. Okay, so that's nice. So now, 7.9 here, 7.9 there. The two middle ones are always the same. Now how do we go from, what is it? From, let's just go liters down to milliliters. So from liter to milliliter, 1, 2, 3 to the right to milliliters. So take that decimal, go 3 to the right, 1, and then 2 more. 7,900. That's 3 to the right. And then this one on the top is the same as the bottom. Top and bottom are the same, and the two middle ones are the same. Now we're moving. Okay, next row. So 1,000, top and bottom are the same. We know this is 1,000. Then let's go from milliliter to liter. So milliliter to liter. Start at milliliter, 1, 2, 3 back to liter. Decimal 1, 2, 3 back. 1.0 or just 1. And the two middle are the same. 1.01. Okay, good. So now 140 on the top, 140 on the bottom. Because again, top and bottom are always the same. And the two middle are the same. From milliliter to liter. So milliliter back to liter again. 1, 2, 3 to the left. So that's going to be 0.14, right? Decimal here, 1, 2, 3 to the left. 0.14, and the two middles are always the same on this table. Okay, last one. 2,300, top and bottom are always the same. Now from milliliter back to liter. 1, 2, 3 to the left. 1, 2, 3 to the left. 2.3, and the two middles are the same. 2.3, there we go. That table got easier once we got the hang of all that. Good. Number 4. Let's see here. We have room for number 4. Okay, number 4. A swimming pool is in the shape of a right rectangular prism, 30 meters by 25 meters. If it is 2 meters deep throughout, how many liters of water does it hold? So it's basically a big prism, if we're understanding that right. So, if I can draw it. Wait, I'm not drawing this so well. So there it is. So it's kind of a rectangular, like a kiddie pool or something. And they're saying it's 30 by 25 and 2 meters deep. 30 by 25 and 2 meters deep. So how much water? Well, the volume of something like this, remember the volume of a shape that comes straight up. Any shape that has the same, any three-dimensional object that has the same shape on the ground and on the top, is the volume, is the base times the height. So what's the base? The base is this rectangle that's on the ground. So that'd be 30 by 25 times the height, which is 2. The base is 30 by 25, and the height is 2. So multiply those together, we're going to get 1,500 cubic meters. 1,500, because that's meters by meters by meters. 1,500 cubic meters. Now, we need to change that into liters. They want us to change it into liters. So how are we going to change that into liters? Well, a couple things we can do. We can use the connection we just saw back here. What is it? Right here. 1 liter is a cubic decimeter. Let's use that. So I'm going to write it up over here to help us remember. 1 liter is 1 cubic decimeter. 1 liter is 1 cubic decimeter. So let's take the cubic meters and let's change to cubic decimeters. So if you're in meters here and you want to go to decimeters, that's 1 to the right. So I'm going to change to decimeters. It's 1 to the right, but then that's third power, so I got to go 3 right. So I got to take the decimal, go 1, 2, 3 right. So 1500, and then add 3 zeros, cubic decimeters. Right, I took the 1500 and I added 3 zeros, cubic decimeters, and then remember, a cubic decimeter is a liter, so that is also how many liters automatically. So that makes sense what I did. I went from 1500 cubic meters, took meters and went to decimeters. 1 jump to the right, but times 3 for the third power. So I went 3 jumps to the right. So 1, 2, 3, added 3 zeros to the back, and that is liters automatically. So 1,500,000 liters of water. Okay, good. Let's go on to number 5, more conversion. I want me to convert each of the following measurements. So now we're working in the grams system for parts A, B, and C. Okay, so let's do it. So we're going to take, let me write it up here again, the metric conversion chart. Let me give a little more room here. So we'll put, so normally we put meters in the middle, right? Normally it's meters, and then this would be decameters, hectometers, kilometers, kilometers. Here is a decimeters, centimeters, millimeters, but we're actually doing grams on this one. So it's grams that's the middle base units, and this is decagrams, decagrams, hectograms, kilograms. This way, decigrams, centigrams, milligrams, like aspirins come in milligrams, very small amount of weight or mass. So, okay, so there's the conversion chart, and we are going to go from grams to kilograms. So if you're at grams, you want to go to 1, 2, 3 back to go from grams to kilograms. So I take the decimal right here and go 1, 2, 3 back, 31 kilograms, 31 kilograms. The next one, we're going from kilograms back to grams. So from kilograms, 1, 2, 3 to the right for grams. So take that decimal, 1, 2, 3 to the right, 34 grams. This one, 4760 milligrams. So now start at 4760 milligrams. So milligrams. And I want to go to grams, so 1, 2, 3 to the left. So take the decimal, which is right. If you don't see the decimal, it's at the end. Go 3 to the left, 1, 2, 3 to the left. So 4.76 grams. So that was super easy because that was conversion in the metric system. We just moved the decimal right or left according to the chart. Now for parts D and E, it's not going to be so easy because all of a sudden now we are back in the English system. So on part D, I'm going to start off and move over here with 0.02 tons. Tons. Now tons, we got to convert to kilograms. That's not going to be easy on that. Okay, but these tons are metric tons. Metric tons. This little T here is metric tons, and let's go find what that means. Looking back here in the notes, it says that little T, metric ton, which is equal to 1,000 kilograms. Metric ton, a person's, so that's it's a metric ton, which is 1,000 kilograms. So, whoops, too far. So metric, so we gotta, so one metric ton is 1,000 kilograms. So that means I'm going to convert this. I'm going to put this over 1, multiply. I'm going to put metric ton down here. I know usually in metrics we convert with just moving the decimal. This one's a little tricky because it's not in our main list up here. So I'm just going to do it this way. So metric tons, and I want to go to what? Kilograms. I'll just do what this says, 1,000 kilograms. 1,000 kilograms is 1 metric ton. So there we go. So we have metric ton, cancel metric ton, and we'll be to kilograms. So I take the 0.02 and multiply by 1,000. So 0.02 times 1,000, that'll be 20 kilograms. So this is 20 kilograms. And then the last one here, E, part E, I think I'll just do it on the bottom here. Part E, start with 23 ounces, put it over 1, multiply. Fractions, right? I'm in the English system now. So now it's English. This was actually metric up here. So it was a metric ton. We also have an English ton, which is 2,000 pounds, but a metric ton is 1,000 kilograms. So it was a metric ton. How did I know? Small little t. That was the symbol for that. All right, so now down here it's English. 23 ounces, going to multiply, going to put ounces on the bottom. What am I trying to go to? Pounds. Do you know the conversion there? I'll go back here if you're not sure. It says 1 pound equals 16 ounces. Do you remember that? So 1 pound is 16 ounces. Ounces cancel. Take your calculator and just take 23 and divide by, they just want a decimal, they said this time. So just take 23 divided by 16 on your calculator, and I'm getting 1.4375 pounds. 1.4375 pounds. Okay, we converted those. All right, the last problem, 6, has got a lot of parts to it. It's kind of a big one. So they want us to find the volume of each of these shapes. So part A, find the volume of that shape. Well, remember how we do three-dimensional shapes that go straight up. The volume is always the base times the height, right? It's just the area of the base, this area that's on the ground, times the height. The height here would be the 2 centimeters. So what's the base? It's 7 by 5. Times the height, which is 2. That's 70. And what are the units there? Cubic centimeters, because it's volume, cubic units. Okay, part B. Comes to a point, it's a pyramid. So the volume of these kind of shapes, again, it's the area of the base times the height, but you throw a 1/3 in front because anything that comes to a point only has 1/3 of its volume. So it's 1/3. What's the base? 7 by 7. 7 times 7 square. And what's the height? It's this 7 coming right down there. That's the height times 7. So use your calculator. 7 times 7 times 7 is 343. These are all over 1, so that other 3 stays on the bottom. They just want us to leave a fraction. So 343 over 3, again, cubic centimeters, because it's volume, cubic units. And part C down here is that shape. So it's a cylinder. It's a right circular cylinder. It's a soda can or a tuna can, looks like, shape on this one. The volume of this kind of shape, let's go back, find it. Back here. Here it is, right circular cylinder. Volume is pi r squared times h. That's area of the base. Again, the base is a circle. Pi r squared times the height. So pi r squared times height. That's the area of the base. The base here is a circle. Pi r squared times the height. So pi, what's the radius? This is the radius here, the 9. Oops, do that a little bit better. 9 squared times the height, which is the 5 there. So that's, what's that? 405 pi. And the units, again, cubic centimeters, because volume is always cubic units. Now, these two are a little more tricky. These are our, we have D and we have E. So let's do D here first off. D is this kind of house shape. We want the volume of this house shape. Well, let's break it into 2 separate questions. We basically have the top up here. This is a prism, right? It's a triangle on this side, and you could imagine the other side, if we drew it in here, would also be a triangle back there. So it goes from triangle to triangle. So it's like a prism sitting on its side. Remember how you figure the volume of a prism? The volume of a prism in any shape that is got 2 of the same shapes, any three-dimensional object that has 2 of the same shapes is called a prism. It's the area of the base. It's the area of the base times the height, area of the base of the prism. Base of the prism times the height of the prism. So, what's the area of the base? What is the base? The base, this is the base. The base is that triangle. This whole triangular thing is the base. This itself is the base. And so it's a little triangle. It's a half base times height. It's a half. What's the base of this little triangle here? This would be the base of this triangle, which is the 40, times the height of this little triangle. Height. I don't know. What is the height of that little triangle? I need the height. That's a little tricky. How am I going to find that little height there? Well, I'm going to need to set up a little right triangle. If this is 40 all the way across, this part must be 20 from here to here, right? It must be 20. From there to there must be 20. And this is H, there, the height. I'm sorry, I'm getting confused. I don't need the Pythagorean theorem. The base is the 6. I'm sorry, the height is the 6, I mean. This is the height. It's the 6 foot they're telling me right there. That little height is the 6 foot. So times, that's the 1/2 base times height for that little triangular base. This little triangular base is 1/2 times 40 times 6 times the height of the prism. This here is the height of the prism. It's just sitting on its side, right? Because the triangle bottom and top are actually side and side. So it's laying on its side, and that's the 39. 39 is the height of the prism. So it's going to be 1/2 times 40 times 6 times 39. So use your calculator for that. and I'm getting 4680. And so that's just for the prism top. Now we need to figure out the base, which is the house and walls. So we already did the prism roof. So we did the prism roof. Now we need the base, the house, and the walls. So what is that? Well, any shape. So we're just doing this shape down to here. Just this right here. Just this shape right here. No roof, just the base. What's that going to be? Well, the volume of any shape that comes straight up, right? This house, the walls come straight up. We're ignoring the roof now. Just the part that comes straight up is the area of the base times the height. So what's the base? What is the base? It's 40 by 39, isn't it? 40 by 39 times the height. What's the height? 18. So that's pretty easy. It's just that. Use your calculator. I'm getting 28,080. 28,080. All right, so now these two, we got to add them up to get the total volume. It's going to be the 4680 for the roof plus the 28,080 for the walls of the house. Add those together. I'm getting 32,760 cubic. Oh, it's cubic feet, isn't it? Because it's cubic units, because it's volume. 32,760 cubic feet. Good. So we figured the roof area, which was a prism, area of the base times the height, and prism laying on its side, and then the base, which is the house and the walls, which is base times height. We added those two together. Finally, this is the last part here. What was that other part? Was D. So this is E. This is kind of a weird little shape here. Got to figure its volume. Okay, so for this shape, it's going to be a little tricky. First off, let's do this little triangle peak thing. Start from the top and work our way down. So that's a prism, right? And remember, for prisms, so it's a triangular prism. It's always the area, the base of the prism, times the height of the prism. Again, this prism is lying on its side. This will be the height of the prism. It's laying on its side. We're letting the triangle bottom and top actually be left and right because it's laying on its side. So what's the base of the prism? Well, it's this little triangle right here. So that's a half base times height. That's a half the little base of that triangle. This base right here, they're telling me is 6. And the little height right here, they're telling me 7. Times the height of the prism. What's the height of the prism? That's the 55, right? 55. The height of the prism. There's 55. So multiply that in your calculator. Let me see. I'm getting 1155. So we're going to have 3 answers. That's the first answer. We're going to add these all up in the end. The second answer is we've got to figure out this shape right here, which is a trapezoid. This trapezoid, and yet it goes all the way to back here, doesn't it? You could picture it, sort of. I'm not very good at drawing that, but I'll just say that. It goes all the way to back here. So it's a trapezoidal prism. But any shape that's a prism that goes same shape to same shape, it's the base of the prism times the height of the prism, right? That's how we figure the volume. The base of the prism times the height of the prism. Again, the height is that 55. What's the base? Well, the base is a trapezoid. Well, how do you find the area of a trapezoid? It's 1/2 base 1 plus base 2 times the height. So it's 1/2. Now, what are the two bases of this trapezoid? The bases are the top and the bottom shapes of the trapezoid. So this is one base, they call this base 2, and this is the other base, base 1. Base 1 and base 2, the top and the bottom there. Base 2 is the 44. Base 1, they're telling me, is 7 right here. 7 is that base. So 7 and 44 times the height. The height is this. It's the height of the trapezoid. That's the 10. Careful, that's the height of the trapezoid. We're still doing the base right here. All this is from the base, plus, and then the height of the prism, or not plus, times the height of the prism. Height of the prism is the 55, right? The whole prism, which is a three-dimensional shape, which goes from here to there, that's the 55. So that's a tricky one. Do you see that? So we had right here, we have the base of the prism times the height of the prism. The prism is a three-dimensional object which has a trapezoid bottom and a trapezoid top. The height in between those two is 55. Trapezoid bottom, trapezoid top, or left and right, whatever you want to say. Trapezoid top and bottom, separated between them with a height of 55. And that trapezoid bottom, it's half base 1 plus base 2 times height, half 7 plus 44 times 10, because this part is 7, this part down here is 44, and this little height here is 10. That's the height of the little trapezoid base, and this is the height of the whole prism. All right, multiply all that in your calculator. Well, first off, we got to add that up, don't we? We're going to have, here, let me figure it out right here. We're going to have a half, 7 plus 44 is 51 times 10 times 55. Multiply that in your calculator. I'm getting 14,025. That's our second answer. So the 1155, the 14,025, we've handled the little triangular peak, the trapezoidal part of the roof, and now we have just the base, the base rectangular prism. So it's a big old just the base, just these base walls, this whole base shape here. So that volume is, how do you figure that out? The volume is length times width times height, right? Because it's area of the base, let me write it again. It's area of the base being a big rectangle, times the height. So the base is a rectangle 44 by 55 times the height. What's the height? 21. It's a big rectangle on the ground, 44 by 55 coming up, 21 feet. Multiply those together. I'm getting 50,820. 50,820. Now, finally, add all these up for the total volume. I'll do it right here. Total volume. So the 1,155 answer right here. The 14,025 answer. And the 50,820 answer. Add those up. And I'm getting... Wait a minute, I realized I messed up in one place back here. This should not have been 7 back here. Sorry. This should have been 6. Right? The base The top base here is 6 and 44. So this should have come out 50. Sorry, messed that up. Times 10 times 55. So this part should have come out 13,750. So that's that answer. That part should have been 13,750. There we go. And so there we go with that. And the total volume is 65,725. There it is. That was a lot of work. So again, I messed up. The one part I messed up was over here when I did the trapezoid. The top base was only 6. I accidentally grabbed the 7, which was actually the height of that triangle. I didn't look close. So this is 6 for the top base and 44 for the bottom base. Base 1 plus base 2 added. 1/2 the two bases added times the height for that trapezoid times the height of the prism. There we go. Now it's correct.